In this chapter, and specifically in this lesson, what we're trying to do here is solve multiple equations at one time. You know, when we have a linear equation like y equals 2x plus 3, or if we just have even a simple one like 2x minus 4 equals 5 and we want to solve for it, or our whole goal is to get the variable by itself, so like x equals 3. Or, and specifically, if we go from a linear to a quadratic and we're asked to solve a quadratic, really what they're wanting us to do is figure out what the x-intercepts are, specifically with the quadratic equation. Okay, so sections here, and starting out here in chapter 5, what our goal is when we're given multiple equations, the key here is to figure out where these equations cross. That's the goal, because where all of these, depending on if there's 2 equations, where those cross, or if there's 3 equations, where those 3 of them cross, wherever they cross that point, so it could be a point like xy, or it could be, if you have 3 equations, it could be something, we're going to have 3 variables like x, y, z, okay? Whichever coordinate, wherever they cross, those x and y values, or x, y, z values, is going to solve every single equation. Both equations for the xy, or all 3 equations for the xyz, and those are very unique points because they're going to be the only points that can actually solve those equations. Okay, so when you go looking to solve linear equations, specifically 2 linear equations, we have options like normal. You can either get no solution, you can get one solution, so specifically one point where they cross, or you can get infinite solutions. And infinite solutions just basically, like what I wrote here, the lines overlap. They're the exact same line. Okay? All right. And if you were kind of curious to figure out, okay, how am I going to notice, when is it no solution, when is it an infinite solution? That's what this whole note here is all about. Is if you go throughout this solving process and all your variables disappear, then just know you're either going to have no solution or infinite solutions. Okay. And what we're going to focus on are 3 different methods to get these. A substitution method, elimination method, and matrices. And these matrices right here is where y'all are going to love it, because this is where we're going to pull out our calculators and spend a lot of time in our calculators. So when we get to this section, if you don't have your calculator out already, you might go ahead and pull it out because we're about to use it real quick. Okay, so let's go on to example 1. Well, here's example 1. I'm actually going to solve this twice. I'm going to do it the first time using the substitution method and the second time using the elimination method, so y'all can just kind of see what each one's all about. Okay, how to do the substitution method. What we're going to do is just focus on one of the equations. So I'm going to just pick this top one. It doesn't really matter, but I'm just going to pick that top one. And what you want to do is just solve it for one of the variables. Okay, so this could get gross, but I'm just going to try to do both methods with this one, just kind of so y'all can see it. But what I'm going to do, let's just say I'm going to solve that top one right there for, let's say, the x variable. So we're going to have 2x is equal to, if I move the y's over, it'll become positive, so 4y plus 5. And then divide everything through by 2, so you get x is equal to 2y plus 5 halves. Okay, so all I did was just rearrange one of the equations. And after I've rearranged it, what I'm going to do now is go back and plug what x equals is into this other one, right there for that x. Okay, so it says now 3 times x, so now it's going to be 3 times what all x equals, which is 2y plus 5 halves. Okay, so 3x plus 2y equals 6. Okay, and this right here is the substitution method. You're subbing one equation into the other equation by, first of all, rewriting the first equation and then just plugging it into the second one. And then from there, if you look at this, everything in purple, it's all y variables. So we're going to be able, by the time we finish this out, we'll just get y equals this, and then we can pretty much be finished after that. Okay, so multiplying this out, 6y plus, let's see, 3 times 5 is 15, so that'll be a 15 halves, plus 2y is equal to 6. Combining my y's, and I'll get 8y is equal to, let's write that as 6 minus 15 halves. And like we always do, if we want to clear any kind of fraction, we multiply through by the denominator. So this equivalent equation will be then 16y is equal to 12 minus 15. Okay, finishing this up. 16y is equal to negative 3, or y is negative 3/16. Okay, that looks a little gross right now, but like I said, this might not be the ideal way to solve this, but I wanted to show you for sure the substitution method. Okay, what we have just found now is the y coordinate. So remember, where these 2 lines cross each other is at a point, and I've only found half my answer. because I only have the y value for it. Now to get the x value, let's go back into what x equals. Well, it says x is equal to 2 times my y value plus 5/2. So the x is 2 times that y value, which is negative 3/16 plus 5/2. All right, so x is equal, let's see, 2 can cancel with that 16. That'll leave it negative 3/8 plus 5/2. And because I'm running out of room, we get kind of common denominators, write them both as 8. So that times 4 and that times 4. So that would be a negative 3 plus 20, or 20 minus 3 is 17, over the common denominator of 8. Okay, so where these two lines, my final answer, for where these two lines are crossing each other is at the coordinate 17/8, comma, negative 3/16. Well, if y'all give me a second, what I'm going to do is I'm going to erase all of this, and let's see if we get the exact same answer if we use the elimination method. Alright, so the goal of the elimination method is basically to start analyzing the variables. Let's compare the x's with each other, and let's compare the y's with each other, and just kind of look at them stacked on top of each other. And just like the title says, we want to try to eliminate one of them. If I just went through here and I added those two equations together, what you would get is 5x minus 2y equals 11. And look, both variables are there. You haven't really eliminated anything. So that's not fun. I could go up here and let's say subtract the two equations, and 2x minus 3x, 2 minus 3 would be a negative x, and a negative 4 minus 2 would be a negative 6y is equal to negative 1, but still, I've got both variables here. So that really didn't help. Okay, but always check for that first, to see if I can use the equations as is. But it didn't work out so well. So what we're going to do is now spend a little bit of time and look really more closely at the two variables. The x's really aren't multiples of each other. 2 and 3, not so much. But look at the 4 and the 2 on the y's. If I just took this second equation and I multiplied all of it through by 2, so that would have given me a 6x plus 4y is equal to 12, right? And I can do that because as long as I did everything, and that's the key, do everything, all on the left and all on the right, then you're good. And then if I just leave this top one the way it is, let's say 2x minus 4y equals 5. So now look at those two. If I go through and just add up those equations, look what happens to the y variables. They're going to go away. So let's write this over here so y'all can see for sure. Okay, so I'm leaving the top equation the way it is. 2x minus 4y equals 5. I'm going to do the brand new second equation, which all it is really still the original one, just kind of a slightly higher magnitude of it, just twice it. And then what I'm going to do is add these up. And you don't always have to add. You can subtract if you want to, but 2x and 6 is 8x. Negative 4 plus a positive 4, the y's go away. And then 5 plus 12 is 17. So finishing this out, we get x to be 17/8. That's really good because that was the exact same x value we got on the elimination or the substitution method. Okay? And now, just like what we did in the substitution, we don't have our full answer. All we have is the x value this time. So we need to go back and get the y value. And whenever you want to do to get the y value, it doesn't really matter which one you plug it in. You can plug it in the first equation, you can plug it in the second equation, or you can plug it in the brand new second equation. Any one of those, you're going to get the same answer. I'm just going to go with the top one, the very first equation, just because. It says 2 times my x value, which I know now, so 2 times 17/8 minus 4y has to equal 5. Okay, so let's kind of reduce this a little bit. 2 into 8 is 4, so that says 17/4 minus 4y is equal to 5. And let's move we'll have negative 4y is equal to 5 minus 17/4. This really isn't that pretty, is it? But we can do this. I'm going to eliminate my fractions real quick before I go any further to make it somewhat easier in my life. Let's multiply everything through by 4 because 4 is my denominator. And I'll get negative 16y is equal to 20 minus 17. So negative 16y is equal to 3, and divide everything through by negative 16, and I get y to be a negative 3/16. And looky there. There's my x coordinate, there's my y coordinate, which is the exact same way. And that should always happen. I mean, when you look at it, no matter which method you go with, hopefully you're going to get the same answer either way. Okay, And like I said, there's a note, a special note. You can check your answer by plugging your values back into both equations. Well, because this coordinate is not looking so fun, I'm going to spare us the grief of that. But just note, you can always plug it back in if you had to. Let's go on to example 2. Here with example 2, if we look at those two equations, honestly, my first thought before I even want to think, do I want to do elimination or do I want to do substitution? Obviously, elimination is a little more easier. I kind of like it. I think it's more fun to do, but it's kind of like more of a puzzle piece trying to get the variables to match up in magnitude so we can just subtract or add. But what I want to do is eliminate all my fractions first. It's much, much easier if you can get rid of your fractions. So here in this top equation, obviously my only denominator is a 2, so I'm going to multiply everything through by 2. And then down here in the second equation, let's multiply everything through by 3. So let's just kind of get a brand new first equation, second equation. So 2 times 3/2 will eliminate the 2, so that'll be 6 over 2, which is 3. So 3x minus 4y is equal to 8. So there's my new first equation, and then the other one will be 3x plus a third of 3 is 1, so y is equal to 6. Okay, so now with this pairing right here, this is where we want to start. And I'm going to do the elimination method again, because like I said, I kind of like it. It's a little easier. And let's look at the variables. We have 3x and 3x, negative 4y and positive 4y. Obviously, look, the x's match up right now. I don't have to do anything else. So in order to eliminate them, instead of adding this time, what I'm going to do is subtract, because you remember my goal is to eliminate. So I want to subtract all of this second equation, and that's the key. If I'm going to do subtraction, I've got to make sure I subtract all of the second. So it's 3x minus 3x, which is 0, and right here, negative 4y minus 1 more. I've got to make sure I subtract all of that second equation. So negative 4 minus 1 will be a negative 5y, and then 8 minus 6 is 2. And wrapping this up then, y is going to be a negative 2/5. Okay, well right there we have half of our answer. Let's go and get the rest of it. And I could plug it in here, I could plug it in here, or I can plug it into any one of those two original equations. It's just those ones have fractions, but if we want to work with them, we could. I think I'm going to go, I don't know, maybe I'll just go with this top one right here. It says 3x minus 4 times my y value, which is negative 2/5, is equal to 8. So 3x plus, this time, 8 over 5 is equal to 8. And let me go and get rid of those fractions. We do this a lot, don't we? Multiply everything through by 5, as 5 is my denominator. So 15x plus 8 is equal to 40. Finishing this out, moving that 8 over by subtracting, 40 minus 8 is 32. Let's divide by 15, and we get x to be 32/15. And from there, since the 15 is only divisible by 3 and 5, and 32 is only divisible, well, it's not divisible by either 3 or 5, then I know that that's my answer. So together, and it's fully reduced, so together, in a coordinate form, the x value is 32/15 and the y value is negative 2/5. So that is technically the answer or the solution to that system of equations. And by the way, you know, I've been picking some harder ones because I wanted to kind of show you. I didn't want to give you the fluff ones. I've been wanting to work with some harder ones. So sometimes you're going to get some pretty answers like the coordinate is 2, negative 5. But I didn't want to go to the easy ones. I wanted to kind of work with you some harder ones. But let's go on to example 3.